Hello friends, in this video we'll be discussing simplex method of LLPP problem number 1. Welcome back friends. Let us start with the simplex method of LPP, that is linear programming problems. One of the most important types. Simplex method, you can say out of every 10 papers, 8 to 9 papers you can expect this type in the exam. Very important type, and it's a very procedure oriented. So if you understand the procedure, you can easily manage the problems. Only tricky calculations are there so that you need to manage. So let us start with the first problem. We need to maximize, and the problem is given here. We have already discussed why this is under linear programming problems, because see, all the terms are linear. In case of non-linear programming problems, that is a different chapter, we'll be having non-linear terms. For example, you will be having x1 square, x2 square, and so on. So this is the given problem. A very important note that you need to remember is this. In simplex method, problem is always of maximization type. Problem is always of maximization type, and all the constraints should be less than equal to. This is called your objective function, and these are your constraint, and this is your by default constraint, so we ignore it simply. So problem should be always of maximization type, and all the constraints should be less than equal to. Now what if given problem is of minimization? Here it is maximize. What if the problem is of minimize, or any one of the constraint or all the constraints are of greater than equal to? So what will happen? That we'll discuss in the next videos. So for this problem, for this video, as of now, conditions are properly satisfied, problem is of maximization type, and all the constraints are less than equal to. Problem is suitable for simplex method. So let us start. First of all, we are going to write it down standard form. First step is fixed in all the simplex method problem, and if you understand simplex method, the next type is dual simplex method, and then we have big M method, that is penalty. All the types are similar, slight modifications, slight changes, and you can manage all the problems. So first problem, it will take time, but if you understand this problem, your rest of the chapter will be very simple. So first step is to convert the problem into standard form. So the problem is maximize z equal to, see here, x1 plus 4x2. Now here in this particular problem, there are three constraints. See, these are called constraints, and this is your objective function. There are three constraints involved in the problem. This constraint we ignore. We ignore this x1, x2 greater than equal to 0. It will be by default in all the problems. So there are three constraints. Therefore, I am going to add 0s1. I am going to subtract 0s1, 0s2, and 0s3. See, ultimately it's multiplied with 0. So you write plus 0 minus 0 doesn't matter. See, what we are trying to do, we're trying to convert this problem into standard form. Actually, this means nothing, but it's a syntax of standard form. And why only s1, s2, s3? Because there are three constraints. Suppose there would be two constraints only, let's say first and 2, then it will be 0s1 and 0s2 only. So number of constraints, that will be equal to number of s, that I'm going to write it down here. After that, all the terms will go to that side. This side it will come, so that is z. x1 will come to this side, minus x1 minus 4x2 plus 0s1 plus 0s2 plus 0s3 equal to 0. So this is your maximize function. Then in the first constraint, 2x1 plus x2, see here, in the first constraint I am going to add s1. In the second constraint I am going to add s2. In the third constraint I am going to add s3. This s1, s2, s3 are called slack variables. They are called slack variables. See, what does this mean? This means LHS is less than RHS. LHS is less than equal to RHS. So in LHS I am adding something so that will be equal to RHS. So simply in the first equation add S1, first slack variable. In the second equation add s2, in the third equation add s3. So let us do it. In the first equation we added s1, 0 s2, 0 s3 equal to 3. We only added s1, so there is no s2 and s3. So this is the format of writing standard form. Next equation, please tell me. 3x1 plus 5x2. In the second equation we going to add s2. That means in this particular equation there is no s1 and no s3. Next, in the last equation, x1 plus 3x2. See, in the last equation I am going to add s3. So here it will be no s1, no s2, and I am going to write s3, which is equal to 5. Now if you observe the standard form, there is x1, there is a x2, there is a s1, there is a s2, all will be greater than equal to 0, similar to this constraint. So this is your standard form, and this standard form is fixed for all the problem. This is your first step of all the simplex method problem, as well as the next step, dual simplex method problem. So hope you understood. Let us move on and let us solve the further part of the solution. Here we need to form a table. The first is basic variable, then we have coefficients of, you need to remember the format of this table, then we have RHS, and finally we have ratio. You need to remember this format of the table. So we need to fill in this particular table. Let us start. Your basic variable is this, to whom I want to maximize it. So basic variable is z. Next, coefficients of. So in case of z equation, see here or here, wherever, what are the coefficients? Coefficients of which term? See, in case of this equation we have x1, x2, s1, s2 and s3. So therefore I am going to write it down here. That is x1, x2, s1, s2, s3. So coefficients of this. Next is RHS, and finally it's a ratio. You need to remember this particular format. Write it down properly, otherwise there will be a calculation mistake then. So let us start. So in the first equation, what are the coefficient of x1? It is -1. Coefficient of x2 is -4. s1 0, s2 0, s3 0. That I am going to write it down here. -1, -4. Then we have 0, 0 and 0. And in this particular equation, obviously RHS is also 0. And there is no ratio as of now. So this is your first entry. Now based on these remaining 3 rows, we gonna fill this particular table. So let us start filling. It is 2, 1, 1, 0, 0 and 2, 1, 1, 0, 0 and RHS is 3. Next, 3, 5, 0, 1, 0. See, it will be 1, 0, 0, then it will be 0, 1, 0, and finally it will be 0, 0, 1. That is for sure. See here, 1, 0, 0, 0, 1, 0, 0, 0, 1. Here it is 2, 1, 3, 5 and 1, 3. 3, 5 and 1 and 3. And what are the RHS? 3, 9 and 5. You should be very careful while calculation, because the calculations are bit lengthy. And here you're going to write it down the slack variables that you introduce. For 3 rows we have 3 slack variables, s1, s2 and s3. Is this clear till now? See, whenever you didn't understand any step, go back and have a look again, you will understand. So this is the first table. Actually this is your first iteration. Now we need to find a ratio here. See the steps. First of all, we'll find a ratio. How to find a ratio? For that purpose, you need to select your key column. So key column, see here, for selecting key column, you're going to check in this particular row, which is above this line. See the line. Above this particular line, between these entries, which is more negative. Which is more negative. See here, -4 is more negative. So this is your step number 1. I'm writing on steps here. This is your first step. Which one is more negative? This is -4, which is more negative. So corresponding to this -4, I am going to make, corresponding to this column, will mark this column, and this column will be called as key column. So this is your key column. Next, what next? Now you're going to divide RHS with the key column. So if you divide RHS with the key column, here the RHS is 0, 0 divided by anything is 0, the ratio is 0. Your step number 2 is RHS upon key column. This is your step number 2. This is called key column. 3 divided by 1, so that is 3. Next, RHS upon key column. 9 divided by 5. Calculation, you have to do it very carefully. 9 divided by 5 is 1.8, and 5 divided by 3. 1.67. So this is your ratio. Then you gonna check which one is your smallest positive ratio. 0, ignore 0. Smallest positive ratio. Smallest positive. See, this is 3, this is 1.8, this is 1.67. Which is the smallest positive? 1.67. We gonna ignore 0, or we gonna ignore negative ratios. Smallest positive ratio. So step number 3, smallest positive ratio, and which is that ratio? 1.67, and corresponding to that 1.67, we gonna select this particular row. This is called your key row. This is your key column. This is your key row. Whatever element is the intersection of key row and key column, this element is the intersection element, that is called your key element. So this 3 is your key element. So we're done with the first table. Is this clear? If not, please pause this video, go back and check again how we made this table, and whenever you want, while copying, please note down the steps so that it will be easy to remember. Let us move on. So we're done with the first table. This is your iteration number 1. Now we're going to solve the next iteration, iteration number 2. For that, again, your basic table heading will remain same, basic variable. Here it will be coefficient of, here it will be RHS, and finally it will be a ratio. Again, coefficient of x1, x2, s1, s2 and s3. Similar heading I am writing here so that there will be no confusion. See here, exactly same column I am making, and here there is Z and here there is a line. Actually we need to join this so that you can copy down the data properly. Yes, now we are ready with the next table. So this is my next table. Yes, let us move on and let us discuss the next table. This is my key element. 3 is my key element. Now for forming the next table, the step is you need to divide this entire key row by 3. You need to divide entire key row by 3 because you want to make key element as 1. It's fixed. Always, whatever is your key element, divide that entire row with that particular element, or basically divide entire key row with the key element so that this element will become 1. So let us divide. So if I'll divide the entire row with 3, here it will be 1, here it will be 1 by 3, here it will be 0, 0, 1 by 3 and 5 by 3. Whatever I am writing with the red pen are your rough work that you can use pencil for writing down. So what we did, we divide the entire key row with the key element so that here it will be 1. What next? With the help of this key element, that means this 1 that we got, you will convert all the above and below elements 0. With the help of this 1, all above and below elements of key column, you're going to convert it into 0. Sorry, I said 1. No, you're going to convert it into 0. That means first of all, let us write it on this row. This is your 1, 2, 3, 4th row. So 4th row, 1 upon 3, 1, 0, 0, 1 by 3 and 5 by 3. Now what next? With the help of this 1, you want to make these zeros. So it will be 0 for sure. Next. Now for making this term 0, see, this is your R1, this is your R2. Just for the reference I am writing, this is R1, this is R2, this is R3 and this is R4. So I hope you are clear with the row operation calculation. See here, with the help of R4, you are making R3 0. So what is the operation that you're going to apply? See here, you want to make R3 0 with the help of R1, R4. See, you want to make this term 0. See here, you want to make this term 0 with the help of this row. So this is your R4, you want to make R3 0. So what needs to be done? -5, because see, forget about this row. For calculation, forget about this row. Assume that instead of this values, we have these values, red pen values. That is 1 by 3, 1, 0, 0, 1 by 3, 5 by 3. Now with the help of this 1, if you want to make this 5 as 0, so this is your R3 and this is your R4. So that will become R3 minus 5 R4. Next. Now with the help of this 1, you want to make this 1 0. This is your R2. So you want to make R2 0 with the help of R4. And finally, you want to make R1 0. And here we have 1. So that will become plus 4 R4. Plus 4 R4. So if I'll apply this particular operations, these terms will be 0. I just need to apply this operation. I need to fill the table. So let us start doing it. Let us start. See here, R3 minus 5 R4. So R3 here is 3 minus 5 R4. This is actually your R4 and not this. Please understand that this is your R4. R3 minus 5 R4. So that will become minus 5 by 3. So R3 minus 5 into R4, and R4 is 1 by 3. So that is 3 minus 5 by 3. So 3 minus 5 by 3 will be 4 by 3. So here it will be 4 by 3. Next, R3 minus 5 R4. So this is 0 that we have already written. So this is 0 and 0. So it will be 0. See here, R3 minus 5 into R4. So 5 into 0, 5 into R4. R4 is 0. So 5 into 0, 0. So this 1 will remain as it is. That is 1. Next, 0 R3 minus 5 R4. R4 is 1 by 3. So it will be minus 5 by 3. And finally 9. See, R3 minus 5. So that is 9 minus 25 by 3. So that is 2 by 3. So here it will be 2 by 3. So we are ready with the first row. Let us move on and let us do the remaining calculations. Next, now we need to fill this particular row. And for filling this row, it is R2 minus R4. So it's very simple. R2 minus R4. See here, 2 minus 1 by 3. R2 is 2 minus R4. So 2 minus 1 by 3 is 5 by 3. This is 1 minus 1, 0. 1 minus 0 is 1. 0 minus 0 is 0. 0 minus 1 by 3 is minus 1 by 3. Next, 3 minus 5 by 3. So 3 minus 5 by 3. So cross multiply. That is 9 minus 5 by 3 is 4 by 3. So we are ready with this row. Let's move on. And next, let's find out the last row. That is R1 plus 4 R4. So R1 is this, minus 1 plus 4 into R4. R4 is this, 1 by 3. So that is minus 1 plus 4 by 3 is 1 by 3. This value is 0. Next, R1 plus 4 R4. So R1 here is 0, 0, and this is also 0, so 0. Next, again 0 and 0, so that will be 0. Next here, R1 plus 4 R4, so 0 plus 4 into 1 by 3, so that is 4 by 3. And finally here 0 plus, see here, 0 plus R1 plus 4 R4, this is R1 and this is 4 R4, so that is 20 by 3. So that is a 20 by 3. So this is your RHS. So we are ready with the table. One more important thing. See here, this is your key column, right? This is your key element. Key element you will get by the intersection of key column and key row. So this is your key element. Key element go this side, S3 go up, X2. That means X2 will enter and X3 will leave. X2 enters, S3 leaves. Whatever element here, key row, that will be leaves and top element will enter. So instead of S3, X2 will enter. So we already have S1, so that will remain as it is. S2 will be remaining as it is. Instead of S3, we are going to write it on X2. What next? We're gonna repeat exactly the same step. What are the steps? First of all, you need to identify your key column. See here, step number 1. See, these steps will be repeated. More negative. Which one is the most negative here? See, in this particular row, there is no negative term. Is there any negative term here? No, there is no negative term here, right? That's it, we'll stop. That's it, we'll stop. And we got our solution. And what is the solution? See here, in place of Z, in front of Z, we have 20 by 3. So this is the value of Z, that is 20 by 3. And obviously it will be a maximum value. Next, X2. In front of X2, in RHS part, we have 5 by 3. One more thing we need to find it out. See here, we want X1, X2 and Z. So we got value of Z, we got X2, we are still left with X1. Here X1 is not there. See here, X1 is not there, therefore X1 value will be 0. So this is your required solution. Is this clear? I hope it's not clear, because see, the problem is a bit complicated. You need to watch these videos twice or thrice to understand the entire thing. Suppose, let us discuss a few more things. Suppose there is some negative number here. See why we stop this procedure here? Because once we are ready with the table, what is the first step? First step is to identify the key column. And how to identify the key column? For identifying the key column, we should have a negative number here. And which is the more negative number, corresponding to that, we are going to find it out the key column. Here, there is no negative number, so therefore we cannot go ahead. Suppose this is your negative number, suppose, assuming. Then this will become your key column. You are going to divide RHS with the key column. See here, RHS with the key column, you will get the ratio, and after that you are going to check which one is your smallest positive ratio. Suppose this is your smallest positive ratio, corresponding to that you will get a key row. So this is your key column, this is your key row. So suppose this is your key element. So what will be the next step? Divide this entire row with the key element and will form one more table. So that is it. But here there is no negative number, therefore in 2 tables we'll stop our work. Maximum in the exam it can go up to 3 tables. If you're so unlucky that I haven't seen yet, it can go up to 4 tables also. See here, for this particular example, it can maximum go up to 3 tables. Why? See here, in the first table, once you make this table, instead of S3 you took X2. Suppose you perform one more iteration, which is not the case here, but suppose is there a possibility of one more case? Then what will happen? Instead of this S2, X1 will come. See, what are the maximum things in the solution? Z, X1 and X2. From this we got X2 because this S3 is replaced with X2. Suppose there is one more step. In that step, this S2 or S1 will be replaced by X1. That is the only possibility, because in the solution we'll get X2 or X1. For this particular problem, there can be one more table if there would be minus here. But here there is no minus. Therefore, we stop. We got the value of Z. We got the value of X2. Here there is no X1. Therefore, we're going to take X1 as 0. Hope this is clear. Please watch these videos twice, thrice, 4 times, 5 times, because all the problems are similar. We'll discuss in the next video one more example of simplex method, then we'll go to dual simplex method, which is exactly similar to simplex method with some changes. I hope this is clear. After watching this videos twice, thrice, 4 times, still if you are not comfortable, don't worry. In the next video also, we'll be discussing this procedure in detail. Thank you.